So we've made it through the hardest part of limits, and now we're ready for limits at infinity. So if you can do the limits as x approaches a number, you are so good to go. This is another type of limit, and this is actually a lot easier. So we did the hard part first, and now we're going to do the easier types of limits without a picture. So we just want to recall from algebra that the line y equals k is called a horizontal asymptote. Horizontal. And then the awful asymptote, A-S-Y-M-P-T-O-T. Horizontal asymptote, which I'm rightfully going to just write as HA most of the time. It's like a vertical asymptote, but oriented this way instead of a vertical way. So it's a horizontal asymptote of the graph if f of x is going to k, which is really the y value, is going to a certain number, not going up to infinity or down to negative infinity, as x is going to infinity or negative infinity. So this, remember, x is the left or the right. So as x goes to the right or left, the y value is approaching some number k. So the y value stops. It doesn't go up or down necessarily. Okay, so let's draw an example of a horizontal asymptote. So drawing our x and y axis, and then putting some sort of graph on here. So maybe let's do a vertical asymptote. Here's our VA, and a horizontal asymptote, just to show them all in one graph. And then a graph approaching them. So something like this. And a vertical asymptote goes up or down to infinity in the y value as you approach the x value. This is just the opposite. X is going out to positive infinity and the y value is stopping at like 6 or whatever that is. So it's just where are you stopping? As x, you plug in 500 for x or 700 for x, the y value is stopping at like 6 on this one. As x goes bigger towards infinity to the right, we're still stopping at some finite number for y. And that's our horizontal asymptote. So it looks like it's going to be kind of complicated, but it's not. These rules are the same rules from algebra, so if you just so happen to remember them, then that's great. If you don't remember them, that's kind of what I'm expecting. They're easily forgotten, but we will totally pick up on them just fine, whether you remember the rules for locating a horizontal asymptote or not. So our rules for finding these limits as x goes to infinity or x goes to negative infinity are going to be the same as our horizontal asymptote rules from algebra. So the rules say find by comparing the degree of the numerator n to the degree of the denominator d. So we need to remember what a degree is. What's a degree? Degree is the highest power of x. So if you have x squared plus x to the 5th minus 1, then your degree is 5 because x to the 5th was the highest one. So all we're going to do is compare the degree of the numerator, which we're going to call n, to the degree of the denominator d. And when we compare them, there are 3 possible things that could happen. So let's start off with the easiest case. We compare the degrees, and the degree of the denominator is bigger than the degree of the numerator. So what I usually call this when the degree of the denominator is bigger, like maybe it has x to the 6, whereas the numerator only has x squared, so you have 6 is bigger than 2 for the degrees. I usually call this, when the denominator is bigger, it's bottom heavy. And the reason why I like to call it bottom heavy is because it starts with a B. And bottom heavy is the best. B goes with B. This is our best case scenario when it's bottom heavy. The degree of the numerator or denominator is higher than the degree of the numerator. The answer is always 0. Bottom heavy is the best. The answer is always 0. So how are we going to see this in function note or in calculus notation? Because this is from algebra. In calculus, what we would see is that the limit as x goes to, and it doesn't matter which one, it could be positive infinity or negative infinity, as x goes to the left or to the right of the function, the graph approaches 0. As long as it's bottom heavy, the answer is always 0. Our next best case is if we compare the degree of the denominator to the degree of the numerator, and we find that they're the same. So this case is called equal. Oh. D equals n. The degree of the denominator equals the degree of the numerator. They're both maybe x cubed. Sorry, I got 0 stuck in my mind from bottom heavy. Degree of the denominator equals the degree of the numerator. D equals n. So we have equal. They could both be x cubed as the highest power. They're both degree 3. If they're equal, then the limit as x approaches plus or minus infinity of f of x, or the horizontal asymptote, they're the same rules. That's how I review it, because as x goes out to left or right, you do get a horizontal asymptote. The limit is the ratio of leading coefficients. It's the ratio of leading coefficients. So I want to be able to circle these words for you. Ratio means we're going to make a fraction out of the leading coefficients, which is the number next to x to the highest power. Reviewing what a leading coefficient is. If you have 5x to the 4th and 4 is the degree, then the leading coefficient would just be the 5 in front of it. So equal sounds like it's going to be hard. It's pretty fancy wording. It's the ratio of leading coefficients. You are just making a fraction out of the numbers next to x to the highest power. Not too bad. It's our second best case. Easiest is bottom heavy is the best. The answer is always 0. Next best equal, make a fraction out of the numbers next to x to the highest power. Everything will always get easier once we do an actual example. So give it just a minute. Our last case, if the degree of the denominator is not bigger than the numerator or equal to the numerator, that means it's smaller than the numerator. That means the numerator's power, or degree, is bigger than the denominator's. This is top heavy. Which is the hardest one. Bottom heavy is the best. The answer is always 0. Top heavy is the hardest one. It's the worst one. And I only say it's the worst because it's where we actually have to do some work for the first time. So to find our answer, we would divide every term by x to the highest power divide every term by x to the highest power in the denominator. So this is the hardest one, just because it's the first one we have to do work on. We're going to divide every single term by x to the highest power in the denominator. The nice part about this is the answer is positive infinity or negative infinity. So you have a 50-50 shot. Even if you just guess on something that's top heavy. It's either going to be positive infinity or negative infinity. So that's kind of the nice part. So there are our rules for limits at infinity, and we're going to use them in the next couple examples.